In the second video of this lab module, we'll model the current configuration of the driver's license office. So recall in this configuration, applicants arrive at approximately 10 per hour. They go through a check-in process where a single check-in clerk checks them in. The applicants then take a written exam, and that exam is administered by one of two exam clerks. And once they finish the written exam, the applicants go to a checkout process, which is done at a computer kiosk, which supports two applicants simultaneously. The performance metrics that we're interested in are the server utilizations, the time in system, and the number in system. So to model this operation, or to model this configuration, we need to model the applicant arrival process, the check-in process, the exam process, the checkout process, the applicant departure process, and then the applicant transfer between the individual processes. So using objects from the standard Simio library, the source object models applicant arrivals. We'll use servers to model the check-in, exam, and checkout processes, the sync object to model the applicant departure, and for the initial model we'll use path objects to model the applicant transfer between processes. So let's look at Simio and build this initial model. So we open Simio, and by default Simio will create a new model. You can change that behavior in the file menu, where you can check the box to load the most recent project at startup. If you don't have that checked, then by default Simio will create a new model. So here we are in the facility view. We have the model selected, and so what we want to do is just drag our objects. So we have our source object, then we're going to have our check-in server, our exam server, our checkout server, and our sync object out. And now let's go in and rename these objects so that we can keep track of them. If you hit the F2 key, you can adjust the name. I'm going to call this check-in. I'm going to call server 2 exam, server 3 checkout. And I'm also going to drag a model entity object from the project library to create our default entity, and I'm going to call this applicants. And so we have created our source and our applicant objects, our check-in, exam, checkout processes, and our sync process, which will model the entities leaving. The last thing we need to do for our initial build is connect the source to the check-in to the exam to the checkout, and the checkout to the sync to model the entity movement. As I said, for our initial model, we're going to use paths, and so I'm going to click on path and connect the output to source 1 to the input to the check-in object. I'm going to click on the path again and connect the check-in to the exam. Instead of connecting these individually, I can also use multi-select, where I double click on the path from the standard library, and then I can connect or add the first path, then add the second path, and so on. You can see that I still have the crosshairs, so I'm still in multi-place mode, and I can hit escape to exit that mode. And so now I have the path that my applicant entities are going to take, and I have my processes, and so now I can go to the quick launch and click on the run and actually watch the model run. I can also go to the run ribbon, and I can adjust the speed factor, and that will let me either speed up or slow down the run. So if I say increase that to a speed factor of 5, we can see that the model is running quite a bit faster. Go back down to a speed factor of 2, and we see that the run slows down. You can see the time elapsed, the elapsed simulation time down in the bottom of the window. And you can see also as the model runs that I can move things around within the facility view. So before we continue building the model, I'm going to stop the model and go back in and talk about the object hierarchy within Simio. This is a very important concept within Simio. It tends to be a little confusing to new users, and so we'll go over this several times. But what I want to point out are the different types or the family of objects. And so over here on the left, we can see something called the object definition. And within the facility view, we see object instances and object run spaces or object realizations. So the object definitions provide the behavior and definition of the individual objects. And so object definitions exist within a library. When I drag an object and place it on the facility view, I'm creating an object instance. So in our model, we have an instance of the source object called source1. We have 3 instances of the server object, the check-in, exam, checkout, 1 instance of the sync object, and 1 instance of model entity called applicants. When Simio runs and creates dynamic run space or realizations of those objects, we see those as they move through the model. So when we click run, we're creating run spaces of the object instance called applicants, which is an instance of the object called model entity. So once again, we have object definitions that exist within the library. We have object instances which are created by dragging onto the facility view, and we have object run spaces which are created as the model runs. If we switch back to Simio and our model is still running, note that we haven't input any of the properties for the individual objects. So the arrival process or the service processes, we just use the standard library objects and with their default properties. And so we're going to use these default properties in the future when we talk about model verification. So by default, the objects are constructed so that a source and a server can process everything that arrives from a single source. So in this case, I have one source that's feeding a server, then I have the server feeding a second server, the second server feeding a third server, and then the entities departing. So we would expect that as the model runs, that we would be able to keep up with the workload, because by default the server properties are coordinated with the source properties so that one server can handle one source. So our next task is to define the properties associated with the individual objects. So I'm going to stop the model and switch back and look at the individual properties that we need to adjust. So for our initial driver's license bureau model, we need to set the inter-arrival time for the source. We need to set the processing time for the check-in, exam, and checkout servers. We also need to adjust the capacity for the exam and checkout servers because they have capacity 2. We had 2 exam givers and the capacity of the computer kiosk was 2. With the sync, there are no properties that we need to adjust. So we are going to assume, since we didn't have any additional information, we just had information on the approximate arrival rate and approximate service times, that all of our time properties are exponentially distributed. And so what we need to do, if we have an arrival rate of 10 per hour, we're going to set the inter-arrival time property to be random.exponential 6. And so this is saying that I want to draw a random number from an exponential distribution with a mean of 6, and I want the units to be minutes. Similarly, for the check-in server, we're going to use the random.exponential 5. Says the approximate processing time is 5 minutes. For the exam, random.exponential 8.8. And finally, for the checkout, we'll use random exponential 9. So all of these are in units of minutes. And then, of course, we set the 2 capacity properties also. Entering and editing object properties is fundamental to doing Simio modeling, and so I want to spend just a couple of seconds talking about the expression editor before we jump in and start editing the properties. So the expression editor you can use to build or edit Simio expressions, and you see that there are a couple of characteristics that are important. So when we look at the expression editor, the things you want to look for are bold values and the little arrows. The little arrows mean that there is a submenu to the current item, and the bold values means that the item returns a value. So in this case, current capacity will return a value. I can look at capacity 1, capacity 2, and so on. Allocation queue will do two things. It will return a value, and there is also a submenu. And so again, you can refer back to this. This will make a little bit more sense as we start to edit the properties. So in our Simio model, let's see the properties that we want to add. We want to go to the source, and then we can expand the properties window, and the property that we're interested in is this inner arrival time. So if I click on inner arrival time, and then I go, when I select that property, I can see the little down arrow. That down arrow means that you can use the expression editor. So I click on the down arrow and it pulls up the expression editor. And we can see the default inner arrival time is 0.25 minutes. Of course, to get our arrival rate, we want to make that 6. So we just type in 6 and we get an inner arrival time of 6 minutes. So for the inner arrival time property, the default was an exponential distribution, and so all we had to do was change the parameter value. When we look at the default for the servers, the server instance check-in, I see that the default is a triangular distribution. So not only do I need to change the properties, but I also need to change the distribution. So I'm going to open the expression editor, delete the existing property, and then we can see that it brings up the expression editor with the menu. And so I can scroll around and I can just sort of look for values that look like they might be what I'm looking for. And of course the one we want is random. Since I have random here and I have the two arrows, we know that there's a submenu. And so I can hit period and it will take me to the submenu, and I can see all of the distributions supported by Simio. I can also just start typing, and as I type, you can see that the cursor jumps to the value corresponding, the menu value corresponding to the expression. So when I get to the one that I want, I can also just hit the period, and that will bring up the default properties or default parameters for that distribution. So I'm going to set this to exponential 5. And click on the checkbox saying OK. And so now we've set that value to random.exponential 5 minutes using the expression editor. When I go to exam, I can use the expression editor, or if I happen to know the syntax for the expression, I can just type that expression. So I'm going to do that, exponential 8.8, and make sure the units are minutes. The other property for the exam object that I need to adjust is the capacity. So I'm changing the initial capacity property from 1 to 2. Also note that when I change the property values away from their defaults, the values are show up in bold just to indicate that you've changed the default. So finally I need to go to the checkout and I need to adjust its capacity to 2, and I need to set its distribution to exponential 9. One other thing I'll mention about the expression editor, if I accidentally type something that it doesn't understand, so for example I forget the L, you can see that the error shows up here in the error window, and so it's saying I can't resolve that random.exponentia, and so hopefully at this point we can recognize that we need to have an L. And when I add that L, it then recognizes the property. One more thing that I forgot to mention on the properties, if I look at the expression editor and then go to get the dot exponential, and I have these two parameters, and one of them was optional. I skipped over this before, but you can see the square brackets mean that you have optional parameters. So for this, the exponential distribution, there's a required parameter, the mean value. There is an optional value for random number stream. So if we see the parameters in the square brackets, that means that those are optional and you can include them or not. So we're not going to use those for the time being. We'll come back and use that at a later lab. So now we zoom out a little bit, get my window situated, and we have all of the properties for our model. We have set the in arrival time to be exponential with a mean of 6, so an arrival rate of 10 per hour. We have check-in exponential with a mean of 5, exam exponential with a mean of 9.9 and 8.8 and a capacity of 2, and we have checkout exponential 9 with an initial capacity of 2 also. And so at this point we can run our model, and we can see it runs a little bit slower, and so we can just increase the speed factor. Let's make it something like 25, and we can see the clock ticking down here as the simulation time evolves, and we can see the arrivals. If we zoom in on one of our servers, our exam server, we can see that we have an input queue, we have a processing area, and we have an output queue. And so these we will talk about in more detail a little bit later, but this shows the entities that are waiting a unit of capacity, the entities that are currently have access to a unit of capacity and are being served, and the entities that are waiting to depart the object. And so at this point, we suspect that our initial model is complete.